Hello, welcome. This is now the next video for D1. Now I did say in my last video, last video, hopefully it's the last one I put up. I was talking about, right, in the next video I'm going to do Prim's and Kushkal's algorithm. Well, actually I was lying now, I've totally forgot. I need to introduce graphs to you. Okay, so in D1 what we've looked at so far is we've looked at algorithms and ways of arranging numbers into different, finding a number in a set of a specific number in a set of numbers, find a name in a set of names. Okay, it's fairly kind of standard stuff. I mean the method's a little bit complex, but you can generally see if you've got it right. Now, what I'm going to go on today is I'm just going to, in this video, I'm just going to give you a bit of an insight into what we mean by certain types of graphs, what I mean by connected graphs, what I mean by obviously disconnected graphs, what I mean by cycles, paths, arcs, lengths, weighted indexes, it's all that type of thing. Okay, obviously we're not referring to economics when we say weighted index. I'm not going to throw such a nasty surprise in there. Well, obviously be a good surprise because pretty exciting economics. Okay, so anyway, that's really for this video. But as I said, I promise you in the next video that I do, I will be doing Prim's and Kushkal's algorithm, unless I totally forget another topic that I need to go over, but I don't think I do. Okay, so as I said, in this video we're going to be looking at graphs and spanning trees. Okay, so the first thing that I want to bring up with you, and just check my okay, so what I'm going to draw, it looks, a graph, generally when you think of a graph, especially in maths, you would obviously think of something like this, maybe a decreasing exponential or some kind of sine or cos graph, okay? Well, quite clearly we're in decision, so we're not going to be dealing with any of that. Okay, so as I said, the graphs that we're going to be looking at in decision are a little bit more, no, they don't really look like any of that, because as I said, it's nothing to do with algebra. It's all sort of a new topic. Alright, a graph is just what we call, it's kind of, it looks something like this. Just basically a load of nodes that are connected together. And we'll call this node A, we'll call this node B, C, D, and E. Okay, so basically a node is you can think of it as where we've got like a dot on this graph. Okay, it's essentially where the direction changes, but you wouldn't specify that. Okay, it's where you see one of these circular dot things. Okay, so that is a node. Now, at these nodes we have something called a degree or a valency. Okay, mean exactly the same thing. But what the hell does it mean? When we generally think about degrees, obviously we think of angles. But a degree, because it's also known as a valency, obviously that is nothing we've heard before. Okay, it's basically the number of lines that are coming off it. Okay, so we've got the line B to A and the line B to C. Okay, so there's two lines coming off B. So therefore, B has a degree of 2. So does A, so does E, so does D, and so does C. Okay, so they all have a line coming off them. Now this line is also known as an edge, okay, which is also known as an arc. So the line is the same as saying an edge, and it's the same as saying an arc. Okay, so just write on what we've said so far. So that's a node. And a node, remember, has a degree or valency, which is the number of lines coming off it. Okay. Now this line, which is also known as an edge, which is also known as an arc. Okay. That is sometimes a weighted index. And what we mean by a weighted index is that A to E will have a value of 8. Now, depending on what the question is asking you about, that 8 can refer to a great number of different things. Generally, because we're looking at graphs, it will relate to a distance. So that might be 8 meters, for example, or 8 units of distance. Okay, but obviously it's going to relate to different things, and you'll get told in the question. Generally it's distance because algorithms are kind of used for sat navs and stuff. But we're going to go on to that in the latter part of D1. Really, just understanding graphs in this video. Okay, So as I said, that's got a value of 8, and the others might have a value of, let's say, 3, 4, 5, 6. Okay, so I've just come up with a random set of numbers. You could have, I've just come up with their numbers. You can come up with any numbers that you want. Okay, but obviously you don't come up with them exact because he is, God. Now this is something called a connected graph. Basically, what we mean by that is there's no parts that, well, basically, we can, if we are at B, we can get to E, even though we can't get there directly, okay, which it doesn't really matter in terms of the words of a connected graph. We can go from B to A and then A to E, okay, so it's almost like vectors, and that's obviously the same as going from B to E. But we still call it a connected graph because from one point on the graph we can get to any other point on the graph, okay? So that's what a connected graph is. Now a cycle, therefore a disconnected graph was something, it might be something like this. If I just remove the line B to A and the line A to E. Yeah, we can still get from B to E, but we can't get from B to A anymore, okay? So therefore you'd call that an unconnected or a disconnected graph, okay? So I'll put them lines back in. Now, there's something else we need to be able to understand as well. So obviously, you could talk about, draw the connected graph and then redraw it. Okay, now what I'm going to draw back is I'm going to draw the back in that line B to E. Now, if we were to draw that in, that is what we call a graph with a cycle in it. And a cycle is basically, when you think of a cycle, it's something that goes round. Okay, and obviously that isn't, but what we're talking about is, you can think of it as a circuit really. It's a connected circuit. Oh, no, it's a wrong word. It's a circuit if you think of it like that. Now, obviously, the true mathematical term is a path. It's a cycle. And a cycle is something where you can go back from one node back to the same node. And when we come to look at Primson-Kashkal's algorithm, that's something that we can't have. Okay, so you just have to remember we can't have a connected. We can't have a graph which has a cycle in Primson-Kashkal's algorithm. As I said, I'll go on to mention that when we go on to that video, but really that's the gist of this. Okay, so basically a cycle is something where you can go from one node back to that same node. Okay, I know, granted this you can if you go around the outside, but it's more something like this that we're concerned about. Okay, now that's the kind of basics. I don't think I missed anything out. There's one more thing that we want to talk about in this video. There's something called a tree. Now, generally you think of a tree, excuse my kind of crude drawing, something like that. My year 6 edition of a tree. But obviously that has no relevance to D1 at all. Maybe you could work out the length of the tree by packing it full of bins, but really that's pretty stupid. You won't do that in real life. You won't be doing maths in real life as well if you had the choice, I'm pretty sure. Anyway, a tree is essentially where we've got a connected graph but there's no paths or cycles. Actually, there's one more thing, sorry. A path is basically this, B to A and then A to E. That's a path. Or B to C. That's a path. Basically, a path is it's like a cycle, but we don't get back to the original node. Okay. So anyway, a tree is tree is a connected graph with no cycles. Okay. So you could call all of these points nodes, but quite clearly we can't connect these two nodes together. We don't connect. Basically, if we were to connect all these nodes together, sort of the branches of the tree, then we would have a connect, and then it wouldn't be a tree. But once we remove these, okay, that is called a spanning tree. Okay, because obviously, if we to use an Primson-Kashkal's algorithm, we can't have a cycle, so obviously we can't go back on ourselves. So once we've gone to one of these nodes, we can't. The only way we can get to another node is go back up the same way, but obviously we can't do that. We've already crossed that distance. Okay, so we've already spanned it, so to speak. Okay. So that's really what this is all about. Now, hopefully, I've not thrown too much information. Just going to give a bit of a recap now on what we've done so far in this video. So we start looking off by looking at nodes, which is just any point where sort of the line turns. It's got a dot on it, essentially. But obviously, the true mathematical term is just sort of a point on the graph. Okay, so B, A, E, C, or D, or C. Okay. And what we went on to say, well, the line between these nodes is something called an arc, which is also known as an edge, which is also known as a line. And sometimes these arcs, lines or edges have a weighted index. What I mean is there's a number associated with that line between two nodes. Okay, so beta A has a weighted index of 3. Okay, what that means is just there's a difference of 3 units between B and A. Okay, so that could be distance, it could be time, we don't know. Okay, so that's what that means. And we also talked about degree of valency, which is just the number of lines coming off a node. Okay, so there's 2 lines coming off B, so there's, if you remove that line, therefore it has a degree of valency, which means exactly the same thing, of 2. Okay, and then we talked about connected graphs, which is what this is. Okay, it's just a graph which is, you can get from one point in the graph to any other point on the graph. A cycle is where you can go almost like a triangle. But as I said, it might be a circle, it might be a square. Okay, we get from one node back to that same node without going down the line that you originally went down. Okay, so a node wouldn't be B to A. Sorry, a cycle wouldn't be B to A and then A to B to get back to B, because see, you'd already gone that distance, you'd already spanned it. Alright, and we said connected, that was an example of a connected graph. A tree is a non-disconnected graph where you can't get from one point to any other point on the line without going on the graph without going back over that same line. Okay, so you can't go from this point to one of the points on the end of the branches and then to the point over there on the furthest right without going back up the original distance you went. Okay, so that is what a tree is. Okay, it's just a connected graph with no cycles. What we're going to go on to now is, in the next video we're going to go and look at Prim's and Kushkal's algorithm. Really, there's no real questions associated with this. Obviously there's going to be questions in the next video, but really that was just an introduction to what we mean by graphs, what certain things mean. Okay, and obviously we're going to be using that a little bit more to enable us to answer a few questions when we introduce the concept of Prim's and Kushkal's algorithm. Okay, but that's really it for this video. Okay, so thanks for watching. Hopefully I've not bored you too much and you've been able to understand a few things about what I've been trying to waffle on about. Okay, so thanks for watching and we'll see you in the next video.